The goal is speed. To be faster than the rest. To win. But with speed comes danger, maybe injury, or even death. A race car must be designed to help the driver cross the finish line first, but it must also be designed to help him cross alive. Randy Sweet, a winner in racing for over 25 years. He's driven all kinds of cars in all kinds of races. Randy has lived racing on and off the track as a driver and a race car designer. Randy has learned from his years of experience that there's more to just standing on the pedal and going all out.
I spent my life 15 or 16 hours a day concentrating on what makes a race car go faster. Racing is a sport, and it's something that you spend a lot of money and time at, and you might as well enjoy it as long as you're going to do it. And I also feel that I can make you a winner at it if you're capable of being a winner. If you're willing to sacrifice and willing to concentrate and work that hard, then you can be any level of a race car driver that you want to.
Randy has worked with some of the greatest names in the sport: Elliott, Trickle, Wallace, and Waltrip, sharing his advice with them. This series of tapes will share with you some of Randy's background, skill, and first-hand experience in racing. His goal, like yours, is to make it to the checkered flag first, and with all his parts intact. This program will cover safety and design of the car, including the cockpit, the footbox, the steering column, and the safety and comfort of the driver in the car.
Okay, the first thing we're going to do is measure the driver to make sure that he fits in the car properly. The way we do that is set him in a straight back chair and measure the armpit so that the seat comes up and supports him properly. So we're going to measure from the base of this chair to underneath his armpit, which is about 20 inches. He likes a couple inches of foam, so the seat's going to need to be 18 inches. All right, now we're going to measure his shoulders. The width underneath his shoulders, right at his arms, is 18 inches. Okay, now stand up, Troy. Okay, his hip area, where he's going to be sitting in the seat, is about 14 and a half inches. Okay, and then if we take right from about that seam there up the top of his shoulders is 21 inches. So that the seat back has got to come that high in order to support him in this area. This point from here, in the base of the seat up to here, has to be 18 inches. This has to be about 17 inches across here. And down here, to keep him tight in the bottom of the seat, we've got 15 inches. The one thing that we've done different is we've brought this arm support around farther. When you only bring the arm support, say, up to here, it winds up where if you do crash, it's in the middle of your rib cage, which is not strong, and then that's how you break a rib and puncture a lung. With wrapping this all the way around you, it gives you something actually to lean on plus take forward impact, and your seatbelt slides right in behind that. And it feels a little funny at first, but it's a lot safer to support the rib cage all the way around than it is to stop in the middle of the rib cage. That is what the seat configuration has to look like. Now the next thing that we've done is we've taken the seat and we've tipped it 1 3/4 inches to the left. It's actually 1 5/8 inches because we take a 2x4 and set underneath that side of the seat. This side of the seat here virtually sits right on the floor, so it's as low as we can possibly get it. And we have the seat tipped like that so that as he drives into the corner, when the car rolls over, it makes his eyes parallel to the racetrack. By the same token, we take this brace and we turn the seat actually this way. so that as he enters the corner, he's already looking into the corner before he gets there. Now we fasten the seat in 4 corners, use 3/16 plate, 3 inches wide, and make L-type brackets in the back. This one is 2 1/4. This one is 1 1/4. We've got them out as far on the seat as we can possibly get them, so that we have the bolt stance as farther apart, so that there again, under severe impact, the back of the seat, this area can compress some and the front of it can move around a little bit. Okay, now that the seat's in position, the next thing that we want to do is we need to put the cushion in the car, and then we need to discuss the proper way to install the seat belts. And there's nothing worse than driving a car that the belts don't pull in the middle of your lap, or that the shoulder harness is wadded up behind your neck, or that the crotch strap doesn't fit you properly, so you wind up not using it. So when you move the seat around like this, then you have to move the seat belts around, and they have to be positioned properly. And you have to have the driver in the car in order to get the right pull on the seat belts. And you always want to pull right straight on the belts themselves. Okay, wiggle around in it and get the cushion down in there where you belong. Okay, now one of the first things that we've done is most of the shoulder harnesses, that's what the hole in the middle of the seat is for, is that they stuff the seat belts through there and have them come off in a Y. And the Y would be right in the back of his neck, and all this big gob is here, and then it's up against the back of his neck, and when the shoulder harness comes forward, to me it always felt like it was going to break my neck. Now where with these harnesses, all you're trying to do is stop the body from going forward, plus contain the upper body in severe rolls or end over ends, and this gob behind your neck just doesn't give you the support that this does. So the first thing we've done is we put a strut across the back here and fastened each seat belt individually. The way we've supported this is steering shaft material. We've come down, went across, up, we've hooked to the cage here, we've hooked to the cage in the middle, we've hooked the cage on this end. We ran one triangle support down to the cage here, so that in an extreme end-over-end condition, he's not going to be tearing the shoulder harnesses out of the car. The other thing that we still have to do is we have to tie a strap from here over to here. Now that we've got everything positioned, we'll have a piece of seatbelt material 1 inch wide sewed across behind the seat, so that if he happened to do a barrel roll, that one of the straps won't come off of his shoulders, but yet he'll still be very comfortable and be pulled into the seat to where he can take forward impact also. So we've had to cut the headrest away on both sides in order to get the belts to run over your shoulders. Then when we cut the headrest away, which made it weak, we wound up putting a piece of diamond design plate on here that comes in a bunch of different triangles to give the headrest enough rigidity to where if he backs into the wall, he still has some support. We've also taken the headrest and run it on a rearward angle so that when he has his helmet on, his head is not against the headrest, because if it is, it has a tendency to vibrate your eyes and you can't see entering the corner. But yet, as he comes back with his helmet on, his head's going to hit the headrest and stop him from breaking his neck if he backs into the wall. Now the next thing is that the lap belts are in proper position. Okay, now plug your lap belt in. Bring the lap belt up, hook it up. Now grab your crotch strap. That'll be the next belt that you want to hook up, because the crotch strap is set at a predetermined length and it's hard to adjust it. So you might get in and out of the car 10 times to adjust the crotch strap. Then once you get it set, all these other points will come to it. Okay, now hook your shoulder harness up without your lap belt too tight. Okay, now start to tighten up your lap belts. And tighten it equally so that that winds up in the middle, so that these things don't eat into your legs too bad. All right? Now start to tighten up your shoulder harnesses. Okay, you've got them pretty well centered. Everything looks tight. Now what'll happen is the minute that you get out there, if you keep this belt here tight, your lap belt good and tight, the minute that you run 3 or 4 laps, the minute you get hard on the gas and slide into the seat, and you'll start turning your body like we've already got you turned. You know how you want to turn in the car, and you're wanting to lean forward, and then stretch on them once now. Pull on them belts. Drive the car hard in the corner. You know what I mean? Like, try to get out of the seat. Try to reef it forward, okay? Now, do you need to tighten your shoulder harnesses up a little bit again?
I probably will, just for safety reasons.
Okay, once the seat's positioned in the car, what we've done is taken the seat belts and wrapped them around the driver. The way the seat belt was originally hooked, it was hooked out here on the frame. First, you're pulling on the hardware on an angle, and you're not pulling tight around the driver themselves. So what we do is seat the driver in the seat, then pull the belt around him tight so that it's on a straight pull. And what we've done is we've hooked this belt, we've made a bracket down here that's hooked off the floor that comes up, catches the rear frame rail, and also wraps around the top of the frame rail so that we have a lot of area to weld to. We use an L9 3/8 bolt in it with a flex lock nut, and don't tighten it completely tight so that the belts are tight, but that as the driver would get to flipping, that the belt can move around a little bit so it doesn't put too much strain on the hardware. The first thing that we did with the chassis is we moved this side rail over, and that's this rail right here. It runs from here up to here. And the way that we originally made it was that it was straight all the way up, and the footbox was a little farther ahead than what it is. Well, all we wanted is the room in here for the driver. Now, I talked to a guy that had got one of the old style cars, and what he is doing was cutting the seat and moving it over against the main rail and kind of accomplishing the same thing that we did here, except that we picked up left side weight plus more room, and I just feel that this will be a lot better situation here. The other thing that we did is this bar here normally runs on more of an inward angle, whereas it runs in like this, which because of the triangulation gives a little more strength. But the way the thing is designed, the way the radius is here, and the way that comes down at an angle, and the way this goes forward, and with this post here, plus we've narrowed the rear cage up, I'm not at all afraid of this bar collapsing right here. And this is the main part that we have to support. That's why this bar comes off from it. Well, when we moved this bar over, then that took this hoop, this top hoop, and moved it over to where it's not over the top of his head anymore, which there again, he's got all that headroom. Even if we had the cage lower in the car, it would still be better with this bar over farther, because of the fact that he could at least hold his head straight. Where you take and move that bar over here where it was 4 or 5 more inches, his head is automatically tipped like that, and there's no way that he can get his eyes pointed in the right direction when he enters the corner. And when he enters the corner, if this bar was up against his head's already turned like that, and he can't come over here against it because of the fact that the way he's sitting in the car, his head's going to be tipped like that, and his head needs to be like this, so that when he gets in the corner, his eyes, with the tip of the seat, the roll in the chassis, that his eyes are parallel to the racetrack while he's in the corner. Plus, you can see that with the seat being cocked like that, his head is already pointed in the right direction to see in the corner. He has less vision block with this post because it runs right along the windshield post, and it just makes it to where it's back to the comfort of the driver. If I take your head and push it over there like that, you're not going to run very good because you ain't going to be able to see where you're going. So if you got your head over here to where when that car rolls in the corner, your eyes are parallel to the racetrack, because your seat's tipped, because you have headroom, then you have a bigger advantage to go fast longer. With this moved over, now he has room for this elbow down in here, where before, if this is over 4 inches, that would have been right tight against his arm. We've changed the triangulation over here to the point where this arm has plenty of room to move without being banged into anything. So now he's got plenty of room without bumping his elbow over on that side, plus he's got plenty of room to move this arm, which this arm doesn't have to move near as much as the right arm. This more or less supports this supports it, this moves it, and the left arm more or less just follows the right arm. So he has plenty of cockpit area. And then still any bar that's close, even close to the driver's head, hands, or anywhere that his arms could fly and contact any of the bars, we pad this with air conditioning tubing. We put a piece of pad across here, we wrap around this corner, pad will come down here, pad comes forward here, another one will come across the top here, and we'll have a complete pad that runs down this whole side here. Any place on this side of the car that when he bangs his arm or his elbow or his knee or whatever against that he don't wind up with a bone chip. Over on this side we'll do the same thing. You can buy the stuff either in round or in sheets. We'll start right about in this area where he could even swing his hand and hit it. We'll pad that from there around that corner. Any place that it's apt under impact that he could possibly bang his arm, his hand, his forearm, any part of his body so that he's not banging right against the steel. Okay, the next thing that we're going to talk about is the footbox area. And what we've done with that is we've determined the width of it by putting 1 foot on the clutch, 1 foot on the brake to determine how wide that area has to be. Still have room to go over and get on the gas pedal. So now we've taken this frame rail, which used to run straight out here, and we've cut that in to make that footbox only as wide as what it has to be. And one of the main areas in the last few years where anybody has been hurt in these cars is in the footbox area, because normally what they have is one piece of pipe that runs down through here and this piece of pipe that runs around here. And because of the way the bumper height is, if you get set sideways at all, they drive either underneath that pipe or through that pipe. There's just not enough tubing in this area to keep them from driving in the footbox. So we spent quite a few days on this, and the object of it is to bring this in so that when this tire, if you hit something with this tire, with that being squared off, it wants to, there's no place for the tire to go except back up inside of the car. So we had to make this corner strong enough so that when that tire hits there, it deflects out. So now we've taken a piece of tubing and went up to this direction and down to that direction, all right? Now that ties this bar from moving up or down. Now we've taken one more piece of tubing and tied it between these two rails. So in order for this to go anywhere, it has to move this pipe, it has to move this pipe, it has to tear this off of here. The most important thing is to make sure that under a panic situation, now if you push that pedal all the way down, Troy, that under a panic situation, when his leg gets straight out like that, the first thing that he's taking a chance of is he's going to break his ankle, or he could blow his kneecap off, or he could break his hip. So what we want is we want the pedals adjusted so that when he's all the way in a panic stop situation, that his leg is arched that much so that under impact, boom, his leg goes up like this. It doesn't break his ankle, doesn't break his kneecap, doesn't break his hip. Okay, the cockpit area is designed as a capsule. This rail over here and this rail here, in order to keep those two from collapsing under side impact, we have this piece of frame rail turned sideways in the middle of them. Then what happens is, put your feet down in there once, Troy. Then what happens is under impact, their feet come back and hit their heel against there, and it'll break their heel off. So what we do, just to personalize the car, we take and put a plate in here so that under impact, when his heel comes back, slide it back. He's going to slide up and over that and not bust the back of his heels. And you also notice the way the gas pedal comes over the top of his foot. That's so to get it all the way down. Okay, now it's throttle spring broke. Pull it back. See, he can pull that back by himself with a toe return. And over the years, I've had the throttle stick 3 times, and it's got to the point where I can't push this one down unless I can pull that one back. If I can't feel that on top of my foot, then I'm not going to hold it down as long as if I know that if something breaks, that I can pull it back. Okay, the last thing that we do is mount the steering wheel in the race car. And the reason that we do it that way is because, first off, we have to think about the driver's legs. And so we have to position the pedals, the footbox, the seat, so that we have the head area for the driver. The last thing is we need is the steering column. Now, if you remember back earlier, we turned the seat sideways. We also tipped the seat over so that as he's turning the corner, the car is already pointed in the corner. So the steering wheel is not parallel to the car. It's on the angle just like it is going into the corner. The reason we run the steering wheel so close to the driver is that when your arms are up close to you, you're a lot stronger than when your arms are out away from you. We also put this pad on here if you're afraid of eating the steering wheel. But if you, in a crash condition, if you let go of the steering wheel, your body's going to flop around in there like a wet noodle. So the farther away the steering wheel is, the more dangerous it actually is. Because the way we design the steering column is so that under a severe crash, he can bend that steering wheel down. In fact, at one time, I hit a wall at Toledo, Ohio, and the steering wheel actually was mounted this high, and when the impact was done, the steering wheel was on the floor and the seat was tipped over backwards, and it didn't hurt me none. Because the fact everything gave as I was taking that impact, and because the wheel was so close to me, I could still hang on to it. The steering wheel is not parallel in the car. The steering wheel is already pointed into the corner just like the seat and the driver is. In other words, everything is twisted so that when you're in the corner, it actually looks like you're straight ahead. And that way he can be much more intense in the corner. His hand should be positioned so that he's not close to a spoke, that he's at like 2 o'clock with this hand and about 3 o'clock or 9 o'clock with this hand, right where he's got it right now. As this hand swings up, it should be in his vision. Now, it's a little high in this car. It should be right below his eyes so that his eye to hand contact are right in the middle of the corner. Now, this column's a little high for him. We make this adjustable here so that he can either adjust it in and out or up and down. By moving this, loosening this bolt here, we can actually turn the steering column up or down to adjust it to his eye level. By loosening this, we can adjust this back and forth to adjust how much angle he can stand. The more angle he can stand, that means the harder he's running, because of the fact that he's always sideways all the way around the racetrack. And if he's sideways all the way around the racetrack, then we put this over here, and then he still thinks he's straight because the steering column is on that angle. Okay, in this tape we've tried to thoroughly cover how important it is for the driver to set properly in the car. That he has to be comfortable and he has to be safe. And he also has to have that feeling that he can pinpoint that spot entering the corner and getting off the corner. And the seating arrangement and the way the steering column and the way everything that we've showed you in this particular video is as important as adjusting the car. If you set properly in a car that's not handling